So today we're going to go over that quiz. We are also going to go through the second part of chapter 4. And you have, which is probabilities of the ors and the ands. You have project 1B due today. However, I think people kind of need another day on it, sounds like, getting some responses back. So you can turn it, you just get it in by tomorrow night. Are there any questions about that? Someone had questions? No questions about the project? Yeah.
We can submit more responses if we get
Yeah.
5.
Yeah. Totally. Yes. So make sure you clean them up beforehand. So in other words, if someone put in like 5.2 for their height, they're really 5.2 inches tall. What they really are is they really mean like 5'2". You know what I'm saying? So you got to convert that to inches and put that in. Or if they put in like under income, they put in like 24,000. They don't really mean they made 24,000, which is 24 million, right? Make that adjustment. Yeah, question? Okay. Good, so clean it up. And if they put in some ridiculous answer, then change it. I will look through those, and I will absolutely ding you if you haven't cleaned it up. Okay. Good. You have some more Connect maths coming up as well. And I think we might have to move exam 1 back a day, a class. I don't know. I'll know more at the end of next class, kind of where we are and what we need to do. But there's a good chance we're maybe shifting that. All right. A sample space. Eduardo, go ahead and read.
A sample space is the set of all possible outcomes of a probability experiment.
Right? So for example, if you roll a dice. If I roll a die, what could possibly happen? What are my possible outcomes? A 1, 2, 3, 4, 5, or 6. Right? So this is a sample space. It's the list of all possible outcomes for a probability experiment. And as a reminder, if you flip 2 coins, you can get a heads, tails, tails, heads, which is not the same, or tails, tails. Here's your quiz problem number 1. Should look like that. Do not leave these all, from every spot, the next one should branch off of there. They should be floating about in space. Right? So they should all be connected. One giant connected tree. Okay? Over here is your sample space. What's the probability of getting exactly 2 tails?
2 of this.
How many of them have exactly 2? Does this one? Does this one?
No.
Does this one?
No.
Does this one? Yes. Does this one?
No.
Does this one? Does this one? Does this one? Not exactly 2, no. So 3 out of 8. What about the probability of getting no tails? How do you get no tails? All heads. Good. So this one's all heads. What's the probability of all heads? 1 out of 8. What about at least 1 tail? So again, at least 1 tail. If I have at least 1 sibling, how many siblings do I have? 1, or 2, or 3. At least 1. When they say at least, you must be at least this tall to ride this ride, that doesn't mean you have to be exactly that tall. You can be taller also. Do you guys see what I'm saying? So at least means this much or more. So at least 1 heads means 1 head or more. All right, so at least 1 tail means 1 or 2 or 3 in this case. So that's all of these guys here. Good. What's that probability? 7 out of 8. Are those 2 related? Do they have some sort of connection, I should say? What's the connection? They're kind of opposites. What do we call that word? What's the official word we use? Complements. Because when you add them up, they make the whole thing. The red group and the blue group make the whole sample space. They're complements. So it means when you add those up, they better add up to 1 or 100%. Jesse, good read?
An event is a specific outcome or set of outcomes. An event could be getting a total of 10 or more when rolling 2 dice. Another event would be getting 2 fours when rolling 2 dice.
So it's just a set of possible, an outcome or set of outcomes. Probability of an event occurring when all events are equally likely. Don't forget that part. Because remember, just because there's only 2 outcomes does not mean there's a 50% chance. I try it for the 49ers, I make the team or I don't. Does not mean I have a 50% chance of making the 49ers, right? Those events are not equally likely. So when all events are equally likely, then the way to find the probability is the number of successes divided by the number of outcomes. So here's your quiz problem number 2. What's the probability you randomly pick a yellow one or a chocolate one? Are those, is there any overlap between those?
Yeah.
Yellow and chocolate? Can you be both? No, so they're mutually exclusive, you just add them. Yellow, chocolate, 8 plus 6 over 20, 14 over 20. The probability you randomly pick a female or a black puppy. So black lab, female lab, is there overlap? Can you be both?
Yeah.
Yes, so they're not mutually exclusive. So which means you have to subtract off the overlap. So this is 8 plus 6 minus 3 over 20. Or you might have done it the other way, which is just looking at it saying, okay, female, that's these 3, and black, that's these 2. Okay, just add up those 4. You could totally do that. So then you get 3 plus 3 plus 2 plus 3 over 20. Either way, you end up with 11 over 20. Doesn't matter which way you do it. Probably you randomly pick a male given it's yellow. Given, again, given means I'm giving you information. I'm saying it must be a yellow lab. That's when you know you have a smaller subgroup. So you're not dividing by 20 anymore, you're dividing by the smaller amount. So given it's yellow, really what you should do is circle. It's not hard to do, it's just one simple thing, just circle it. Given yellow. So what's probably it's male? 4 out of 6. That will save you a lot of headache of trying to figure out what things to put. Okay so far? Okay. Here's quiz problem 3. This is from your homework. And I think they should put lines in it. That's why I brought it in here, because it's a lot easier if you just make lines. That looks a lot like the puppies. Right, so then it's totally like the puppies, and you just put your totals in here. 4, 10, 18, 32, 6, 26. And then I think it's a little bit easier to solve. So when you're doing this on your homework, feel free to just make a little table like this on a piece of paper and just use that. Otherwise, if you have to stare around and get confused, it's not worth it. It'll save you, taking 30 seconds to draw this picture might save you 2 or 3 minutes. Especially if you get it wrong, then it might save you like 5 minutes. Okay, so what's probability someone is a pediatrician? So pediatricians means they study pediatrics. How many study pediatrics? 10 out of 32. All right, everybody take 15 seconds with the neighbors, find the next one, and I'll randomly call on someone to give the answer. Looks like I'm sorry, what'd you end up with? Oh, yeah, so I'm sorry, how'd you find it?
You add the probability of being a orthopedist,
Uh-huh,
plus the probability of being a MD.
uh-huh.
You subtract the probability of being a MD and orthopedist.
So you did that way? And then also, or some people could have just added those 4 things together, that's fine too. Either way, you get 29 out of 32. Good. Did anybody have questions or problems with the homework? So I'll just point out a couple things real quick. One is, when you're doing it, I'll say it one more time. See this 7 to 10? So it'd go between 7 and 10. If you go down and grab the next one, you can't put it here. It will give you an error, even though your thing graph looks good at the end. This says 13 to 16, it has to go in the 13 to 16 section. So if you use the wrong stick in the wrong spot, even though your graph looks exactly perfect, it will say it's wrong. So the 13 to 16 stick has to go between 13 and 16. This stick, the 10 to 13 stick, has to go here. The other issue people had was on the pie chart, which is here. Yeah. When you put these in, the last one, this last one here, you have to put it in, even though your thing already looks like. Hold on a second. Okay. So you put your 6 in. I think you have to click here and then click there. Oh, maybe not. I don't know. Put your 6 in. Oh dear. There we go. Okay. So this looks like it's all done, right? But you still have to put this one here from the center to the top, even though it's already kind of there. If you don't put that one in, it'll mark it wrong. So, do you guys following? So don't forget to put that last one, even though it looks like it's done, it's really not. Okay. Probability rule number 1. How about, Carl, go ahead and read for us.
Probability of any event E is a number from 0 to 1 or 0% to 100%. This is denoted by 0 is less than or equal to E.
Probability of
Probability of
E.
And this is less than or greater or equal to 1.
Perfect. And then just read this part down here.
Probability cannot be negative, nor can it be greater than 1 or 100%.
Good. Probability rule number 2. Angelo.
The sum of the probabilities of all the outcomes in the sample space is 1, or 100%. You can't have 50% chance of heads and 25% chance of tails and 0% chance of anything else.
Right? So we add up all the probabilities in the sample space, is darn well better equal 1. Here is your quiz problem from number 4. Make a table. So I will ask you this. What are the 2 things you know about a pizza? There's a pizza. There's 2 things you know about it. What's the first thing you know about it? If it's cheese, or whether it has one or more toppings. What's the other thing I know about it?
Where it's
Yeah, where it's eaten, whether it's eaten at work or not eaten at work. Like since it was eaten at work, and since you didn't say anything else, then the complement must be not equal to eaten at work. So those are the 2 things you know about it. So you can make a table from that. You can say it's either cheese, or it's 1 plus toppings, 1 or more toppings. And then you know that it's either at work or not at work. And then you have totals, right? These are the things out here are your spots to total things up. So given that, Once you read what you've got in there, put numbers in, figure out what numbers you have, and try to, we've given you 4 pieces of information, 4 numbers. Once you know where those 4 numbers go, you can find all the rest. Okay, so we know the 25 goes where again? Oh, geez, yep. Where's the 19 go? And then the 14 cheese pizzas we're eating at work, where does that one go?
First upper left,
Yep. And then the 11,
right next to it, right.
right below it?
Oh,
I
that
did
one,
it a different
yeah.
way. All right, so then, can I find these other 2 spots here?
Yeah.
Yes. If I have 25 total, 14 are at work, that means that the rest of them, 25 minus 14, 11, were not at work. And here, I have 19 one topping plus,
Right.
and I had 11 at work. That means that the rest of them, 8 of them were not at work. And I can just add to find these other numbers. Okay,
But
so then the other question is, what's the probability of a cheese pizza not eaten at work? Cheese not at work is 11. And there's no given, so if there's no given, it's always out of the total. Given is the only time where you have a smaller total. Otherwise, it's always out of everybody. So 11 out of 44, which is indeed 1/4. Like somebody asked earlier. Yes. Okay. Complementary events. Ashley, L. Go ahead.
The complementary of an event E, denoted by E is the set of
E-bar.
E-bar is the set of outcomes in the sample space that are not included in the outcome of event E. Is everything that is not E.
Right, it's also written E with a little c, E complement, that little c up there. And as we talked about last class, it's kind of obvious, the probability of something happening plus the probability of that not happening had better equal 1 or 100%. Right? Probability that you are wearing a red shirt plus probability you're not wearing a red shirt should equal 1. Kind of what goes along with that is if I were to subtract the probability of E bar from both sides, I could find the probability of an event is 1 minus the probability of its complement. So we did that last class, right? The probability of somebody picking somebody and having them not like vanilla is 1 minus probability that they do like vanilla. That was that one with the 23% of people prefer vanilla thing we did last class? Okay. All right. Now let's just get a little more practice with trees before we get going. I have a box. In this box is a $1 bill, a $5 bill, a $10 bill, and a $20 bill. It's in a box. I draw one. What could possibly happen? What could I possibly draw? I could draw a 10, I could draw a 1. There's a bunch of options, right? I should have a spot for each option. Then I do not replace it. I keep it. And I draw another one. So whatever you pick for this happening, then you draw another one. And from there, what can happen there? So go ahead and make a tree for this. You're drawing twice. You are not replacing in between. So you can't draw a $1 bill both times.